We're going to look now at ionic compounds and how to write both the formulas and how to name them. And before we get going on this lesson, make sure you have with you, in front of you, your data booklet and specifically your periodic table of elements from your data booklet. This is going to be absolutely necessary as we work our way through chemical formulas. Well, first thing though, the chemical formula is really just a way to write a compound in a shorthand method. We don't want to write out the words each time. We want to come up with a convention to write these compounds in a shorthand method. Now, the beauty of the chemical formula is it actually describes the proportions of the component elements. So how much of each of the elements are together in the compound. Now, the important thing that we're going to do when we do these chemical formulas is we have to write chemical formulas that have an ion charge of 0. So the positives and the negatives have to equal each other, so there's no charge or a balanced charge of 0. Now the first one we're going to look at is the simplest form. It's called a binary ionic compound. And a binary ionic compound is unique because it's only formed with 2 elements. And if you remember, ionic means it's a metal and a nonmetal. So we're just going to take a metal and nonmetal, or a positive and a negative, and write the formula. When we do that, the positive, the metal part, comes first, and the negative, the nonmetal, comes second. And when we combine them into a formula, we're going to include subscripts. Subscripts are numbers below, and the subscripts are actually going to show how many of each element is needed in this binary ionic compound. So let's write some formulas. And the formulas are actually quite simple if we just follow 2 basic steps or basic premises. What we always need to write the formula is we need the symbol and the ion charge, and that can come from the periodic table. And once we have the symbol and the charge, then it's just some simple math to balance the charges to make sure that we have equal numbers of positive negatives, and we can complete the formula. So we're going to do a series of examples here, and let's start with our first one here. Let's imagine we are combining calcium with oxygen. So the first thing we need to do is turn to our periodic table and find calcium and oxygen. And if you look on your periodic table, number 20 is calcium, and number 8 is oxygen. We can find both the charge and the symbol by looking at the periodic table. There's the symbol and charge, Ca, and oxygen has the symbol O with a charge of -2, and that's what we need to write our formula. So we take them from our periodic table, and we have calcium, which is a 2+, and oxygen, which is a 2-. Now we have both the symbol and the charge. Now we can complete the formula. Now what we want to do, notice here, is that the charges of these 2 elements must balance. But have a look here. They already do. Calcium is a 2+, oxygen is a 2-. The charges are already balanced, the same number of calcium and oxygen. And so because of that, we have just 1 calcium and 1 oxygen. So we just combine them together. 1 calcium, 1 oxygen. Our symbol is CaO. Well, let's try another. Potassium with nitrogen. So the same steps we did before. Turn to your periodic table. We'll find potassium and we'll find nitrogen. And what we want to look for is the symbol and the charge. The symbol and the charge for each one. And we take that symbol and charge and we write it down. Potassium is a 1+, or just a plus. Nitrogen is a 3-. And now we need to balance the charges. Well, we don't have enough pluses here. We only have 1, and we need 3 pluses to balance that out. So just think about going to your periodic table, grab another potassium. Now we have 2 plus and 3 minus. Still not enough, so grab another potassium. And now have a look at our numbers. The potassium charges are 3 plus. The nitrogen charges are 3 minus. What happens here is the balanced ion charge. And now we just count how many potassium we have, how many nitrogen we have, and we have 3 of the K's, so we put a subscript 3. We have 1 nitrogen. Now, we don't write the 1 in, but we can assume that it's there, and there's our formula, K3N. Let's try another. And what I'd like you to try right now is pause the video and see if you can do the formula for aluminum with sulfur. Now that you've had a chance to try it, let's go over it. So, you follow the same steps. Aluminum on the periodic table is Al with a 3 plus. Sulfur on the periodic table is S with a 2 minus. So, we'll write them down. Notice the charges aren't balanced, and we need the same number on each side. Well, let's just grab some more from the periodic table. And now we have a charge of 6 pluses and 4 minuses. We just need 1 more sulfur, and then we have 6 positive, 6 negative. The charges are balanced, and now we can write the formula. Now, if these were combining together, this is what we have. We have 2 aluminum combining with 3 sulfur, and we get the chemical formula Al2S3. Well, what if we have compounds that are multivalent elements? And multivalent is just an element that has more than 1 charge. And if you look on your periodic table, especially the transition metals, they can form ions that have more than 1 charge. The good part about this is we're going to be told which charge to use. So we'll look at the periodic table, look in the middle at one of the transition metals, copper. And if you look at copper, you will notice that copper has either a 2 plus or a 1 plus. It is multivalent. It has more than 1 charge. So when we look at copper, it could either be a copper with a 1 plus or a copper with a 2 plus. And what we're going to do is we're going to say, okay, I'm going to come along and tell you we want to work with copper with the 1 plus, and we want to combine it with oxygen, which is always a 2 minus. The charges aren't balanced right now. We need some more copper. And now we can look at our charges. We have plus 1 is plus 2. Oxygen is a 2 minus. That means we have 1 oxygen and 2 copper. And our formula is Cu2O. Well, again, I'd like you to try and pause the video and see if you can write the chemical formula for manganese 3 sulfur. Well, let's go over this. Manganese 3 sulfur. Now, manganese you have to be careful about, not to confuse it with magnesium on your periodic table. Manganese is number 25, and it has 3 different charges, 2 plus, 3 plus, or 4 plus. We are working with manganese 3, so we know the charge is 3 plus. We're combining it with sulfur, which always has a charge of 2 minus. So, there's what we're starting with. Manganese 3 plus, S2 minus. And you're often going to see this combination of 3 plus and 2 minus. And we'll see a pattern that starts to emerge. We need 2 manganese and 3 sulfur. That will balance the charges. We'll have a 6 plus here and a 6 minus here, which means we have 2 manganese and 3 sulfur, Mn2S3. Well, what about naming? And naming is just as important as writing the chemical formulas. Now the first thing we want to know is that the chemical names come from the ion names. The ion names. And if you remember, we named our ions by taking the nonmetals and ending them with IDE. So let's look at an example. Here is NaCl. This is sodium with chlorine. But chlorine is a non-metal ion, which means it's going to end in IDE, so we actually get sodium chloride. Same could be true with K and O. K is potassium, O is oxygen. Oxygen is a non-metal ion, which means it ends in IDE, and we have potassium oxide. Now notice these names, there are no subscripts in the name. We never put the subscripts in the name, we just put the words in the names. Now if we were trying to name something that is multivalent, we do have to indicate the charge, and we're going to use Roman numerals to show the charge. So Roman numerals are going to become important. So we have something like Cu plus and O2 minus. Remember, that is copper with a charge of +1 with oxygen. So we would write this name as copper 1 with the Roman numeral and oxide. Now see if you can try, and you may want to pause this, the next one. So this one, we have Mn3 plus with S2 minus. Always look to your periodic table. Mn3 plus is manganese. S is sulfur. Sulfur is a non-metal, so we have manganese sulfide. Now the important thing here is that the Roman numeral is shown, and the Roman numeral is the ion charge. It is the charge of that multivalent ion. So very, very important that we show the ion charge.